Learn. Yeah, now that we're recording, now we can learn. All right. So cylindrical shells. In the past, we've taken a region, right, and we revolved it around the x-axis or the y-axis or some other horizontal or vertical line, and we get this solid figure, right? We get a solid geometric shape, right? Geometric solid. We call them geometric solid, right? Well, and we've sliced them. That's what we've been doing. We've sliced them in a certain way, either horizontally or vertically. So the cross sections of those things are either circles or they're circles with another circle cut out of them. True? Okay. And we summed all those together and found the volume. Well, instead of slicing them, what we're going to do now, we're going to take the same idea. We're going to take a region. We're going to revolve it around an axis. But instead of slicing it into little pieces, we are going to take what we call like hollow shells of that region. So we're first going to imagine if we imagine the entire solid. Where did all those little wooden things I had go? Anybody know? Nobody knows. All right. Imagine this without the end to it. Pretend it's just like a nice little cylinder, right? We're going to imagine a cylinder that is the size of the outer portion of this, but completely hollow on the inside. Okay? And then sitting right inside of that is another cylinder that's just slightly smaller that slides right inside, that fits perfectly inside of that other cylinder. And then imagine inside of that next one, another one that's just slightly smaller than that, and then another one that's slightly smaller than that, and another one that's slightly smaller than that, and so on and so on and so on, until you've filled up all of the space inside of this solid. Does that make sense? Okay. So that's the concept that we're going to use, except we're going to apply it to any region that we want to revolve around any axis. You can sort of think of it like what are they called? The Russian nesting dolls. You guys know what those are? Right, the little, I don't know, you might have them when you were a kid or something. You open up to take the head off, you decapitate the first one, right? And then right inside of it is another one that looks exactly the same, but it's a little bit smaller. Right, you take that one out, and you're like, oh, cool, I can rip this one's head off too. And then like inside of that is another one that you can rip the head off of, and another one that you can rip the head off of, and they fit nicely inside of each other. That's what these shells are going to be. And what we're going to do is we're going to find the volume of each of these hollow shells and then sum those together. Instead of finding the volume of a little disc or a little washer, we're going to find the volume of the shell and add them all together. So we're going to say that they have, that thickness that they have is going to be infinitesimally like thick, right? So it's think about like a toilet paper tube, right? When it's empty, right? That's pretty thin, right? Well, this is infinitesimally thin. It's so incredibly thin that you cannot even see that there's thickness to it. And so that's going to be our dx or our dy, whatever direction that thickness of the shell or the cylinder is going. Does that make sense? Okay. So suppose we had a hollow cylinder. How would we find its volume? How would we find that? What would we do? Not quite the surface area, but close. We'd find what we call the lateral surface area. Because the surface area also includes the bases, both bases, right? But if we think about just the lateral surface area, just the area going around it, right? And then we multiply it by how thick it is, which is going to be infinitesimally thin, right? Which will be our dx or our dy. So it should just be the lateral surface area times the thickness of the shell. And what would the lateral surface area be? How do we find the surface area going around? 2 pi r h, exactly. 2 pi r h. And then for our purposes, since we need to register how thick it is, we have to multiply it by the thickness. So 2 pi r h times the thickness should give us the volume of one of those shells. Okay. And so the way we think about this then, depending on what your function might look like, you might have the next shell might stick just slightly out of that one, but the inside of it, okay? So like it might be just a little bit taller. And then the next one might just be a little bit taller than that, but then fits inside of it. just based on whatever the function's graph in the region that you're looking at looks like. So, you know, these monkeys are going to get narrower, but they're going to keep sticking out further. I don't know why I put a bunch of dotted lines there in the middle of it. That's the question. But these might just keep getting taller and narrower until we filled up all of the space that makes up that solid. Does that sort of make sense? How these are going to work? Akashi, okay with that? Well, it depends on what the region looked like. So suppose that the region I was revolving around the x-axis, or well, in this case it'd be around the y-axis. Suppose the region I was revolving around looked like this, right? So then each, you know, on the other side, it has the same thing going on. And so cylinders going up would be getting narrower, but they'd be getting taller because the region would go up higher. Like if this, you know, if this y value, the cylinder would just go straight around. If the next y value would go around. So we have here, then they'd be narrower, narrower, and narrower. So you got the point where it was just basically like a revolving swing. Does that make sense? Yeah. Any other questions in here about conceptually what we're going to do? People at home in the Zoom, are you okay with that conceptually?
Yeah.
Wonderful. All right. So our steps are as follows. We're going to graph the region, and we're going to sketch what we call a typical rectangle. That sounds a little bit weird, but when we talk about sketching a typical rectangle, that's going to help us to determine if we're doing it in terms of x or in terms of y. So, for example, with this one that I was just talking about, I would, if I were revolving around this axis, I would sketch a rectangle, right, that was parallel to that. And then what I would do is I would revolve that rectangle around the x-axis or around the y-axis in this case, right, to get one cylinder. And I would do it with any arbitrary rectangle going across. And each of those rectangles that I would revolve will be parallel to the axis you're revolving around, and it will make one of those cylinders. And so if I think about the rectangles, in this case, we're going around the y-axis. If I think about the rectangles as parallel to that, the thickness of them is going to be very small in which direction? In the x. Yeah. But what do you mean? Yes, I think I'm understanding your question correctly. I think so, yeah. Does everybody see that that one should be dx? If we go around this y-axis, right, so the thickness here is dx. And so then we're going to find the radius. The radius would be the distance from here to here. There's your radius. The height is just the height of it. And it's 2 pi, radius, height, thickness. So we would need the radius and the height to be in terms of x, because our thickness is dx. Okay. If we were going around the x-axis, okay, then the thickness of each of those rectangles that we would draw would be dy, and we need to do everything in terms of y. So we'll sketch the rectangle, we'll sort of, sketch a shell, we'll draw a cylinder going around, we'll find the radius, we'll find the height, or altitude, height, whatever. And then we'll use 2 pi, radius, height, times thickness, and then we'll just use an integral to sum all of these arbitrarily sized shells together from, in this case, we do it from this x value to this x value. Does that make sense, everyone? All right, let's see if we can do one of these. Let's start with one that already has everything labeled out and has a nice picture that I stole from the textbook from it. Yeah, that'll be good. So we've got the function y equals the square root of x. function we should be familiar with, I hope. Okay. Y equals the square root of x, and y equals the square root of x is going to get revolved around the x-axis, it says here, from 0 to 4. So if we're revolving around the x-axis, that means that when we sketch the typical rectangle, right, any arbitrary rectangle anywhere within here, it has to be parallel to that axis. So my x-axis is, I've got it at sort of an angle to try and make it look three-dimensional from the textbook I stole from. Horizontal, but that's parallel. That rectangle is parallel to the x-axis. And when I revolve that thing around here, right, we end up with this cylinder that's hollow. I did my best to like get rid of some of the color, so you can see that it's hollow. It's a hollow cylinder that has a thickness in the, what direction is that? It's very thin in which direction? In the y direction. So this has a thickness of dy. And you'll find that anytime you revolve around a horizontal axis and you're trying to use shells, you will do it in terms of y. Anytime you try to revolve around a vertical axis, you're using shells or z, which is the opposite of what we would have done if we were doing it in slices. But if I were to slice this thing, right, what would I end up doing it? I do it in terms of x, right? Because the thickness of each of those slices would be in the x direction. Right? So this gives us the opportunity, if we need to do something in the other variable. Right? So if for some reason there's some issue with using a disc or a washer, you can instead try to do it with shells and use the other variable. Does that make sense, everyone? At home, are you good with that?
Yeah.
Oh, wonderful. Okay, so now we just need to find the radius. We need to find the height, and we've got the thickness. So then we'll just integrate 2 pi r and then times the thickness. So our radius, and you will find this is very convenient. Your radius, whenever you are revolving around the x-axis, your radius will always just be the distance from the x-axis to the function. And that distance is always going to be y. And you'll always just be able to use y if you're going around the x-axis because you need it to be in terms of y. You won't actually have to write out square root of x. You'll just use y. Because that radius is going from the rectangle to the x-axis. That makes sense, everyone? And as far as our height of the rectangle is this distance right here. Okay? And so the right-hand bound of our region is always the line x equals 4. The left bound of our region is the function. So we could say that this height is 4 minus x, right? Like we did before, we called this x. The whole thing was 4, and we did 4 minus x. But because it has to be done in terms of y, we rewrite y equals the square root of x as x equals y squared to make this, as they label already, 4 minus y squared. Does that make sense, generally? Prakash, you good with that? Now you're delirious because you've been awake so long already. You're getting slightly tired. Or that. Everyone's good? No questions? Zoom questions are good.
Good.
Okay. Great. So now we write our integral. We could do 2 pi times the integral from the highest to the lowest, the lowest to the highest, the left to the right to the left. What do we need to do? What variable are we using? Y. So if I'm using y, I need to go from the bottom to the top, right? So 0 exactly to 2. So we're going to do 2 pi integral 0 to 2. And then we had our radius, pi. We had our height, that was 4 minus y squared. And we'll distribute that y through. and then we will integrate. Does that make sense? The setup, just like with discs and washers, the setup is the part that's difficult. The rest of it is just, some arithmetic and some basic calculus stuff, right? So 2 pi times the integral of 32 of 4y minus y cubed, which is going to give us 2 pi times 2y squared minus y to the 4th over 4. And obviously, if we plug in 0 to that for the lower limit, that's going to be just 0, so we can ignore that. What do we end up with? We end up with, looks like 4 inside of the brackets if we plug in 2. 8 minus 4. So 4 inside of there times the 2 pi. 8 pi units. Everybody good there? Now this one, using shells was really not that helpful because could we have done this using disks? Yeah, the region was fully pushed up against the x-axis. It actually would have been a hell of a lot easier. A heck of a lot easier. I'm getting back into my being in the classroom where I don't care, but now I'm recording. Yeah, we could have just revolved it around the x-axis and sliced it into disks. And what would we have done if we had done that? 0 to 4 of root x. Right, if we revolve that around the x-axis, slice it, we do it in terms of x, dx. We do pi times the integral from 0 to 4 of the radius. What's the radius? Root x, right? That's our radius. So it would just be root x squared. So this actually would have been a lot easier. And note that what do we get? We get x squared over 2 times 5 from 0 to 4, which gives us, again, pi. Right? Gives us the exact same thing. And this particular problem was not easier to do using shells, right? But sometimes they will be. Sometimes it may be impossible for you to convert the variables from x to y in order to solve the problem using disks or washers. But you can leave them in the original variables that are given to you and use shells. That's a helpful tool to have. Just because it was not easier this time doesn't mean it isn't sometimes easier or necessary. Everybody good there? Yeah. All right, let's take a look at this one. What does 4 minus x squared look like? That. And we're going to y equals 3x. And bounded by x equals 0. There's 2 of these regions right there. Let's say the region bounded region. We're going to call this the region in the first quadrant. We're going to just use the region in the first quadrant. But there are 2 regions there. So we're talking about this region, this region right there. That's the region we're talking about. Everybody good with that? Zoom good with that? We're going to use this region right here. Okay, cool. All right, and we're revolving this around which axis? The y-axis, right? So if I'm going to revolve around the y-axis, what's the first step here? We sketched the graph, we found the region. What's the first step after that? Sketch a typical rectangle. That rectangle should be parallel to the axis you're revolving around. There it is. There's my typical rectangle. Sketch in the region parallel to the axis I'm revolving around. Then we'll sketch the shell, which just means I'm revolving that little rectangle around the y-axis. I may have revolved it a little bit too far, but that's fine. Then we just need to figure out what is the radius, what is the height, and what is the thickness of that cylinder. So first off, what's the thickness? Should be dx because that rectangle is very thin in the x direction. So our thickness is going to be dx. What about our radius? Our radius ought to be the distance from the y-axis to that rectangle. Well, how do we measure a distance from the y-axis to something to the right of it? We call that x. Can I just leave the radius as x? Yeah, we're doing dx. Just leave it as x. That's fine. Okay. You'll note that anytime you are revolving around the y-axis, okay, and you are doing shells, your radius will be x. Just like I said, if you're revolving around the x-axis, your radius will be y. Okay, that's true. If you revolve around the y-axis, your radius for shells will be x. 100% of the time. Never a time when that is not the case. Okay. All right, so we got the thickness, we got the radius, we still need the height. The height is just this distance, right? True. How do we measure that distance? It's the distance between the two curves, right? It's the distance between the upper function and the lower function. No matter where I move in this region, if I drew my rectangle over here, that height would still be the distance between the upper function and the lower function. No matter where I am in that region, that's always the case. Does everybody see that? Zoom, do you see that?
Yep.
Great. So how do I find the height? The distance between the two functions. How do you find the distance between two things? Subtract them, right? So it should just be the upper one, 4 minus x squared, minus the lower one, 3. Good or no? All right. So our integral that we should set up is 2 pi. Then we need radius, we need height, we need thickness, x times 4 minus x squared minus 3x dx. And we need limits of integration, which should be x values or y values? X values, because we're doing everything in terms of x. The furthest left point of my region is 0. The furthest right point of my region is this intersection point. Yes? We need to find that intersection point. How do we find an intersection point without our calculator? Set the equations equal to each other. So what do we have? We have 4 minus x squared equals 3x. Or x squared plus 3x minus 4 equals 0. Factor that. What does that factor to? Ought to be x plus 4, x minus 1. So it looks like those things intersect at x equals -4. That'd be this one. And x equals, that'd be that one. Everybody good with that?
Yep.
Yeah. Zoom, you're good?
All good.
Wonderful. All right, then we can integrate if we want. First of all, to distribute that through, it's 2 pi integral 0 to 1. 4x minus x cubed minus 3x squared. So that's going to give us 2x squared. Don't break your 2 pi. 2 pi times 2x squared minus x to the 4th over 4 minus x cubed, all from 0 to 1. And the 0 again will be 0, so we can ignore that. Just plug in the 1. We got 2 minus a 4th plus 1. All right. Yeah. 3 minus a 4th should be what? I'm not sure what that was all about. But.
How did our x cubed become positive?
Good question. It shouldn't have. That's weird. So we have 2 minus the 4th minus 1. So we have 1 minus the 4th. Or 1 minus the 4th. That's an easy question, children. What is 1 minus 1/4? 3/4. There we go. Okay. And we have 3/4 times 2 pi. This should be, if I multiply 3/4 by 2, that'd be 6/4, which would be 3/2. So we have 3/5. Everybody good with that or no? Yeah. Sure. Anybody have any questions on that? Everyone's good. Zoom, you're good.
Yeah.
Wonderful. Everybody here is good? All right, that's great. Let's do this one and the other one. We're not going to evaluate some of these. We're just going to sort of set them up because the evaluation is kind of boring. They're all fairly easy integrals to do usually. So we got 2x minus 1, x equals 0, and the square root of x. 2x minus 1, square root of x, and x equals 0. We're looking at this region right there. And what are we going to revolve around? Y equals -2. And we know that's way below this region, right? I mean, not way below, but it's one full unit below the bottom of the region, right? Because 2x minus 1 should cross through the y-axis at -1. Yeah. All right, so as we revolve that around, first thing we need to do is we need to sketch a typical rectangle. That typical rectangle should be parallel to the axis we're revolving around. Y equals -2 is the horizontal line, so we should draw that rectangle horizontally, which means that that rectangle is going to have a thickness of dy. The dy. Then we're going to revolve that around this line. There it is. I've done it. That is beautiful. What's the radius? It would be cool if it was just y again, right? But it's not because we're not going around the x-axis. We're just going around something that is parallel to the x-axis. So first, what's the distance from the x-axis to the line revolving around? That's 2. What's the rest of it? From the x-axis up to the thing we're going around, the rectangle.
Y.
So our radius ought to be 2 plus y. Everybody good with that? Notice that for y values that are negative, because there are some negative y values in this region. Y'all at home can hear that, yeah?
Yeah.
Okay, all right. Just make sure you don't think I'm like nuts or something. Everybody hears that sound, not like hallucinating sounds. Anyway, everybody good with that being 2 plus y? If we had a negative y value, right, like let's say y was -0.5, then that radius would be 2 plus -0.5. It'd be 1.5. So it still work even if we're below the x-axis. When we're above the x-axis, like 1, let's say, that radius becomes 3. Good? What about the height? The height is just the distance from here to here. Well, that's just the difference in the x values of the two functions. Just like the height on the previous problem was the difference in the y values of the two functions. This time it's the difference in the x values. So let's see, we have y equals 2x minus 1 is the line, that's the rightmost one. So we have y equals 2x minus 1, what does x equal? That should be y plus 1 divided by 2. Yeah. So that's the rightmost x value is y plus 1 over 2. And what is the leftmost x value? Well, that comes from y equals the square root of x. What is that x value? It's x equals y squared. So to find the height, we need to do the rightmost function, y plus 1 over 2, minus the leftmost function, y squared. That should give you, now we've got our radius, we've got our height, we've got our thickness, we should be able to set up the other. Does that make conceptual sense to everybody? At home, Zoom? People here? You okay, Riley? Are you sure? Because the y plus 1 over 2 is to the right of the y squared. Yeah, because we're talking x values, right? To find the distance between them, we take the larger x value, subtract the smaller x value. The larger x value is the one that's further to the right. The smaller x value is the one that's to the left. Does that make sense? You look like you weren't 100% happy with that. So that's why I stared at you and said, "Are you okay with that, Riley?" Okay, good. That's what I do to children. Stare at them until they admit that they don't know what's going on for a second. It usually works. Everyone's good now? All right. Okay, so we set up our integral. 2 pi times the integral of t. In terms of y, the lowest y value in this region is down here. What's that y value? We should know that's -1 because that line is 2x minus 1, so it has a y intercept of -1. And then the highest y value is up where square root of x intersects with 2x minus 1. You could probably figure out what x value makes that true, just pretty easily. What x value makes that true? I mean, you don't even need to really like do any work. You could just say that happens when x is 1, right? If you just kind of plug in some easy values, you see that x equals 1. If x equals 1, then y equals
1.
I need to note that this is y equals 1 that I'm integrating up to. Right? I mean, I don't need to put the y equals there, but we just want to note that just because when we intersect they get x equals 1, that's not the one we're using. We're using the y equals 1 that we get if we plug 1 into either of those equations because we're going from bottom up. Does that make sense, everyone? Riley, you good with that? Okay. All right. Making sure. Okay. Everyone's good? Zoom, good?
Yep.
All right. 2 pi, -1, 1, radius, height. If I was really mean, I would make you distribute all of that out and evaluate this, but I'm not going to do that. I am really mean, but just for the sake of time, I don't think we'll do that. Conceptually, okay? Yeah. Oh yeah, I did, didn't I? Because that's what we should have done here. That was stupid of me. And then I did the problem later on, huh? Did I do the problem twice? Yeah, no, that's right. I screwed up. Yeah. What we're going to do here for 1 second is we're going to pretend that I didn't screw up. Yeah. So I just said that. As soon as you said that, I said, oh yeah, I should have done that. Pretend like we cut this off here. Pretend like we were working there. This would be a 0. Everybody agree with that? Can I cut that off there and just ignore this part down here? We all agree that would just be a 0 as the lower limit. Nothing else would change. Yeah. That's correct. This looks perfect. What's the problem with what I just did? All this other stuff. Not all of it, but a little bit of it. Bad of me. Wasn't paying attention to what I was doing. Yeah. Why would I have to do two separate integrals though? Because what? Nothing to do with them being negative. Good thought though. Anybody at home see why I should do two integrals? Yes. So for this piece down here, the rightmost region is the line, 2x minus 1, but the leftmost part of the region is just 0. It's not the square root function. So that was my fault. That was me being bad and not paying attention to the region very carefully. Okay. I'm glad you said that. Here's our root x, here's our 2x minus 1. We'll note that from -1 to 0, from -1 to 0, the right part of it is 2x minus 1, but the left part of it is just 0. But from 0 to 1, the right part is 2x minus 1, the left part is from root x. You all see that? Everybody at home see that?
Yeah.
Okay. So if we were trying to do the entire region from -1 to 1 in terms of y values, we should have done this. 2 pi times the integral from -1 to 0. And is that going to affect the height? I'm sorry, is that going to affect the radius? The radius would still be that 2 plus the y value, right? Because the y is going to be negative there. So the radius would still be 2 plus y. But the height from -1 to 0, the rectangles in this piece, are just y plus 1 over 2. And then we have to add to it an integral from 0 to 1. 2 pi. And then we have all this same stuff, 2 plus 1. Y plus 1 over 2 minus y squared. Does that make sense? Why we have to split it into 2 and how we got both of the different things? Yes. Does that conceptually make sense to everybody? Did Zoom home Zoom people good? Or no?
Yeah.
Okay. Thank you for pointing that out there. That's good. That was bad. All right, let's talk about what happens if we revolve around the line y equals 5. And this time, let's just take the easier region just for the sake of making it easier. Let's take this region right here. Suppose we wanted to go around the line y equals 5. How will that affect the integral? When we sketch our typical rectangle, it doesn't change, right? When we revolve it around, right? Does that change the height of the rectangle? Does height change? No, the height should still be whatever we had before. What was it? Y plus 1 over 2 minus y squared. But the radius will change. What will the radius become? Radius is minus 1. Okay. So if you switch the line that you're revolving around using shells, in terms of, if it's already a horizontal line and you just move that horizontal line somewhere else, the only thing that's going to change is the radius. The height will stay the same. The thickness, dy, will stay the same. The 2 pi will stay the same. The limits of integration will stay the same. Okay. This will just become 2 pi times the integral from 0 to 1. Our new radius, 5 minus y. times our height of y plus 1 over 2 minus y times our thickness of dy. Yeah. No, we did 2 plus 1 because that was below the region that we were working with. Now that we're above, it's got to be, because the full distance here is, that's 5, right? From y equals 5 to the x-axis. And y is the distance from the x-axis to the function. So the radius is full 5 minus the little y part. Does that make sense? Any questions on that? Everyone's good. Okay. We sort of have the idea. We should do a little bit, one more, and then we'll be good. Yeah.
Why is this one only from 0 to 1?
Well, I just specifically called it that region this time.
Oh, okay, okay.
If we'd done it from -1 to 1, we would have had to do that same thing where we split into 2 integrals.
Perfect, thank you.
But still, the only change would be the radius. Everything else is still the same. All right. And so real quickly, we're just gonna, and I'm not gonna, normally I make everybody evaluate these ones, but we are now 8 days away from that May 4th AP test for some of you. So we're gonna make sure that we have plenty of time for review. So we're not gonna bother to evaluate these. But this is a good example of why I think it's really important that people know shells, because trying to do this problem using discs or washers is impossible. Okay? And even though the College Board doesn't require you to know shells, I think for anybody that's going to move on to a second semester calculus course, you need to know how to use shells. Otherwise, some problems could potentially be impossible for you to do. So we have the function x equals 12 times y squared minus y cubed, which I've sketched the graph of right there. And we want to revolve that region that's enclosed between that function and the y-axis. So this section right here. And we're going to revolve it around the x-axis. So if we were to do that, we would sketch our typical rectangle. Right? Which would have a thickness of, actually, let's move back. Let's not sketch a typical rectangle. Let's just revolve this region around the x-axis. Okay. So I revolve it around the x-axis. I get some other thing down here that looks like this. It's 3-dimensional or whatever. And if I tried to slice it, I would have to do this in terms of what variable? X. So I have to do this in terms of dx if I were to slice it. And if I had to do this in terms of x, I'd have to find the radius. Well, the radius would have 2 different values, right? I have an outer radius and an inner radius because my region is not fully pushed up against the x-axis. So I'd have to have 2 radii. Well, the problem with that is the first radius is whatever this y value is, right? That's my outer radius. And my inner radius is this, but both of those come from the same function, don't they? And I need to have them as x values. So I would have to solve this thing for y to get multiple different x values. That's going to be an issue, right? Because the same function is defining both the outer radius and the inner radius. You guys see that? Yeah, that's a problem. That's a problem. You guys see that's a problem in Zoom?
Yes.
Now that you,
Big problem.
Yeah, big problem. That's right. This is the issue. I just stand there and wonder why nobody in the Zoom is saying. Didn't screw that one. All right. So now let's try to do a shell, and we'll see how easy it will be. So there's my typical rectangle with a thickness of dy, which is great because that means that I can do everything in terms of y. And all my crap up there is in terms of what? X equals 12 times y squared minus y cubed. All right, so what is the radius of this thing? I revolve this around, the radius should just be exactly y. As we already talked about, if we're going around the x-axis, the radius is y. What about the height? The height ought to be this distance, right? That's my height, which is just that. Well, x is just 12 times y squared minus y cubed. So this ought to become 2 pi times an integral of my radius, y, times my height, 12 times y squared minus y cubed dy. And I need to integrate from, what's the lower part of that region? Looks like it's hitting the origin, right? And if x is 0 and y is 0, that satisfies that equation, right? So bottom is 0. What about the top? What else makes x 0?
One.
1, y equals 1, right? X equals 0, if y equals 1. 1 squared is 1, minus 1 cubed is also 1, so 1 minus 1 is 0. So that would be our integral. Everybody good with that? If I were evaluating this integral, I would pull the 12 out into the front and not have to worry about it. I'm not going to make us evaluate the integral. Right? You just pull the 12 out, distribute, integrate, value. It's not that complicated. I don't want to spend the time on it this exact moment. What if we wanted to go around the line y equals 1? Would that affect the thickness? No, it'd still be dy. Would it affect the 2 pi? Would it affect the integral from 0 to 1? Would it affect our radius? Yes, our radius would be different. What would our radius be? Now we're going, our radius looks like this, right? So our radius would be, what? Almost. Yeah, flip them around. Y minus y. Right? 1 for the full thing minus the y that we've got. So our radius would change to 1 minus y. So this becomes 2 pi times the integral from 0 to 1 of 1 minus y times the 12 times the y squared minus the y cubed dy. The height doesn't change, right? Everybody good with that? Zoom, good with that?
Yeah.
Okay. What if I run around the line y equals 8/5? What would my radius change to? Eight fifths minus y. So we have 2 pi, integral 0 to 1, 8/5 minus y, still have a 12, still have a y squared minus y cubed, still have a dy. This is the problem I usually finish the year on, which is very exciting because this one comes out to equal 2 pi exactly. It's just very cool. We get to end the year finishing with a 2 pi. Yeah, that's the concept of shells. That makes sense, everybody? Do they have any issues with shells? Questions on shells? I will post an assignment that is all shells, just so you can practice it. But especially for those of you that are May 4th test people, you will not have to use shells on the AP test. There is a small chance that it might pop up. I will not quiz you guys on shells. I will put up the one assignment to practice. So those of you for May 4th, I would recommend not really even worrying about it too much and just focus on the rest of the stuff that's going to be on the AP. The rest of you, it'd be good to know you got an extra, you got like a month from now until you're taking your test, so, or more. So spend the day to learn shells and really understand it in case it pops up in a future. Everyone good? Any questions? Everyone's good? All right. And did you guys all start working on the area and volume FRQs 1 through 6? Is that what I asked you guys to work on? Because I thought we'd have more time, but we'll have time to do at least the first 1 or 2. You guys all did those? Yeah? Okay. So we're going to do number 1 right now. Yeah? Okay. Actually, before I start doing number one, which we're gonna do it right now anyway, but this is the first one I asked you guys to do, right? Yep. Because I want them all to be up there, and we're gonna try and do as much and vary the different types of free responses we can this week. I'm going to put up about five more assignments, I think, 4 or 5 more assignments that are different specific types of free response questions that you will see on the AP test. And so for those of you at the May 4th test, like try and get through and do as many of those as you can in the next week. And I will go through a few of them of each type during this week. The rest of you are going to spend a lot more time with each of those, and we're going to have quizzes on each type as we go through, but obviously we don't have time before May 4th. So just keep an eye out for that. There are also, and I'm not posting them in Google Classroom, but I'm going to tell you this every day this week. There are, I believe I have 4, there might be 5 full-length practice tests that are up in Google Drive. They're not supposed to be given to children as online resources. It's supposed to be like printed off and used in the classroom, but because this year is this year, I'm just posting them there. I'm not putting them up like in Google Classroom for the world to see, but if you know how to get into my Google Drive, you can find them in the assignments folder. So especially for those of you that are taking the test in a week, you probably want to go through and start doing some of those. So those are up there. So look for them. I want to say it's 2012 to 2016 at least. The full tests are up. Cool. Oh, somebody said something in the chat. Oh, on the test, so they specified to use shells or slides. You can use whatever you want. They will never require you to use shells on the test, on the AP test. They will never require you to use shells. No problems will require shells. You are welcome to use it if it's easier. Everybody good with that? Okay. All right, so let's take a look here at this first free response question. This one, let's see. This one was a non-calculator one, it would appear, surprisingly. Oh. Yes, the answer keys are embedded within the practice tests. So they're all the answers are in there. Okay, so we've got a function g of x, which is 2 plus 3 cosine pi over 2x, and h of x, which is 6 minus 2 times x minus 1 squared. You'll have to figure out which one of those. Which one of those is which? Is the upper one the cosine, or is the upper one the parabola?
Parabola.
The upper one is the parabola. We should be able to tell that the bottom one couldn't possibly be the parabola. It shouldn't look like a parabola. Right? So the upper one is your parabola, the bottom one is your cosine function. Question A is find the area. So how do we find the area between two functions? We integrate, right? The upper one minus the lower one. And we're going to integrate from where to where? Since we're doing this in terms of x, probably, that seems like the easiest.
1 to 2. 0 to 2, 0 to 2, 0 to 2.
0 to 2, yeah. So we're going to integrate from 0 to 2. The upper function, like we said, 6 minus 2 times x minus 1 squared. And then minus the lower function of negative 2 plus 3 cosine pi over 2x dx. Everybody good with that generally? Then let's go through and evaluate it. So the 6 and the minus the negative 2 is going to give me what? 8. So I'm going to have 6 minus negative 2 is 8. I'm going to have 8 minus 2 times x minus 1 squared. And I'm going to have minus 3 cosine pi over 2x. So that's the thing that we want to integrate. What's the integral of 8? Should be 8x. What's the integral of minus 2 times x minus 1 squared? It requires a simple u sub, right? Because it's a function squared. But you will note that anytime if your u sub, And if you do u equals x minus 1, what's du? Just dx. If that happens, if du equals dx, you can just go ahead and integrate as if this was u squared. This is 2u squared, so that would become minus 2u cubed over 3. So minus 2/3 x minus 1 cubed. Okay. And then what about the last piece? What is the integral of minus 3 cosine pi x over 2? Yes, it should be minus 6 over pi sine pi x over 2. If you're not sure how we got that, we got a minus 3 cosine pi x over 2. Right, this is a function pi x over 2 within another function, so you have to use of u equals pi x over 2. So du is pi over 2. So when you do that integral, right, if you're trying to integrate this, you'd have to multiply by a pi over 2, which would mean you'd put a 2 over pi on the outside. Does that make sense to everyone? So that's how you get 2 over pi, and then that just becomes minus 3 cosine u, which just becomes minus 3 sine u, but you have the 2 over pi. Cool. And then we evaluate from 0 to 2. At 2, we end up with 16 minus 2/3. This becomes minus the sine of pi. What's the sine of pi? 0. So we got 16 minus 2/3 minus 0. And then if I plug in 0 to all of these, well, to the first one there, we end up with 0. And the second one, we end up with a plus 2/3. And then with this one, we're going to take the sine of 0, which is 0. So what do we end up with? 16 minus 4/3. What's 16 minus 4/3? 44/3? Yeah. Conceptually okay with that, everyone? Or no? Yeah. All right. Wonderful. Part B says region R is the base of a solid. And so this region that we've got is the base of a solid. The cross section is perpendicular to the x-axis. So this is our cross-section area that we started with when we first started doing volumes, right? So we can sum together all of the cross sections to find the volume. So it says each cross section perpendicular to the x-axis. If it's perpendicular to the x-axis, what variable are we going to do this in terms of? For cross sections. The thickness of each cross section should be dx, right? And it gives you the area. It tells you the area. No matter what, the area of each cross section is 1 over x plus 3. Well, what was our formula to find the volume if we had the cross-sectional area? All we had to do was, what did we have to do? Right, that was the formula, right? The integral from a to b, in this case 0 to 2 of the area, right? Well, it doesn't, in the past we had to find a formula for the area, right? Usually on the AP test, you have to find a formula for the area. This year, whatever year this one was, they didn't require you to do that. They said, here's your area. So effectively, all you're doing is integrating from 0 to 2, 1 over x plus 3 dx. That's it. Easy enough? Yeah? Okay. How do we integrate 1 over x plus 3? Right? You can do a u substitution. Sure, u equals x plus 3. Du is just dx, right? So we can treat that as just as if it was just a u. So what's the integral of 1 over u? natural log absolute value u. And we're going to go from 0 to 2. So this becomes natural log of 5 minus the natural log of 3, which is a perfectly acceptable answer. If you want to write it as natural log of 5/3, that's fine too. But either of those would be good.
When we get the AP exam, are we gonna just get a paper like this slide and just have to write all over it, or is there like a separate sheet that we write on?
Yeah, it'll be like this, and you just write all over it. But they give you like between a half a page and a full page for each part.
Perfect, thank you.
You'll have plenty of room. Everybody good with that for part B? Any questions there on part B? All right, what about part C? And you'll note that part C on a non-calculator test, oftentimes on the non-calculator portion, oftentimes they will just ask you to write the expression for the integral, kind of like we did with those last 3 that we just did, but you don't actually have to evaluate. Sometimes, they don't always do that, but sometimes they do that. So we're going to take this region and revolve it around the line y equals 6. Okay? And like I said, we should always go to do these with discs or washers. This one will end up being washers, right? Because the region that we're revolving around that axis is not fully pushed up against that axis. Everybody sees that? Okay. All right, so what is our outer radius? Should be the distance from y equals 6 to the lower function. All right, well, that lower function has a height of y at any x value that we go across. And so the difference between that should be 6 minus y. So our outer radius will be 6 minus, what is it, g of x. And our inner radius will be 6 minus h of x. Does everybody see that? Or no? Serena, you okay with that back there? Okay. Everybody in Zoom okay with that?
Yeah.
Okay. So part C, your answer should be pi times the integral from 0 to 2 of 6 minus g of x. That was our outer radius, right? I forgot which one was g and which one was g. Yeah. Minus 6 minus h of x squared dx. And if they define those as g and h and you don't have to evaluate or anything, this is perfectly acceptable. This would get you all the points. Okay. If you wrote out g of x and you wrote out h of x, that's fine. Nothing wrong with that either. But you don't have to. You can just write g of x and h of x. Everybody good there? Any questions on that? All right. So we have like 1 minute, so we'll just stop there. Tomorrow, we're cutting ourselves close on time for May 4th, people. But tomorrow we're going to do at least 2, 3, and 4, maybe 5 and 6 of those free response. And then we are 100% for sure going to do the anti-differentiation multiple choice after that. And I'm going to give you guys, I want to do at least 1 problem in class also of the next type of free response, which I will post tonight. And then I'll probably have you, actually, I probably won't post that one tonight. I'll probably just have us do 1 together in class so we can talk about it, and then have you guys, then I'll post it tomorrow and have you guys do more of it tomorrow. So do as many of these area volume problems as you can tonight, and then that should be good. Everybody good? Any questions? Everybody good? All right.